I'll do 12 and 13 together. They're both asking about steps in the hypothesis testing process. What I'm going to do, though, is for 12 and 13, I'm going to do the entire hypothesis testing process, and I'll just show what the answer is. But I want to do the whole process just so you can see it a couple of times. So a recent survey of gasoline prices indicated that the national average was $4.98 per gallon. So that's the national average. So we'd say that's the population average. Population mean. Right? When they did this survey. The Dallas Automobile Club claimed that gasoline in Texas was significantly lower than the national average. So the club is making the claim that gasoline is lower than this national average. So a survey covering 10 suburbs, so that N equals 10. In that survey, we found the average price, X bar, was $3.924 per gallon, with a population standard deviation of $0.053. What critical value should be used to test the claim using alpha as 0.01? That's all the information from the problem. That's all the information we've been given. So the steps of the hypothesis testing process, and there's two different approaches. So I'll do the traditional method, and I'll also do the p-value method. Show both. Traditional first and then p-value after. So step 1, and if you're a little unsure about the steps of this process, they're actually on the formula sheet right before the z distribution table here. We've got the steps for the traditional method and the steps for the p-value method. First step of both, state the hypotheses and identify the claim. That's the first step of both. So step 1, we'll do both together then. State the hypotheses, null hypothesis and the alternative hypothesis, and say which one is the claim. So the null hypothesis is always the statement of equality for our text. So it's the population mean hasn't changed. It's $4.098, right? Per gallon. It hasn't changed. That's the null hypothesis. It remains as it always was. Now the club is claiming that gasoline is lower than that average. The club is claiming that the alternative hypothesis is that gas is less than that. That's the alternative hypothesis, that is less than. The alternative hypothesis can be less than, greater than, or just simply not equal to. In this case, less than. So that's the first step. Second step, so I'm going to continue with the traditional method. Second step here, find the critical values from the appropriate table. Now we've done a couple of problems before with finding critical values, right? And that's actually what the question is asking. So the question is essentially asking step 2 of the traditional method. Okay? So if we remember, so if we think about it, right, this is a less than, this claim, this is the claim. Right, that's the claim. This claim is that gas is less than. So what we're talking about is a left-tailed distribution, and that alpha here, that alpha is 0.01. And when we're finding the critical value, I want to know what this value, this z value is here, right? Z value, because we know sigma, we know the population standard deviation, z distribution. Which z value here, it yields this 0.01 area to the left. Now the simplest way to do that is, again, go to the t distribution table. Left-tailed test. If it was greater than, it would be right-tailed. Not equal to would be two-tailed, but this is a left-tailed test. So look at this. Look at how nice this makes it. One-tailed, that's to the left, right? One-tailed. And the alpha value is 0.01. One-tailed alpha is 0.01. Go all the way to the bottom for z, 2.326. 2.326 or 2.33 in our textbook. So this value here is not 2.33 or 2.326, it's negative 2.33. That's the answer to the question. That's the answer to the question. Negative 2.33. Or negative 2.326, whichever one you see. Okay, so that's step 2. Step 2 of the hypothesis testing process. Find the critical value. Now the third step, step 3, compute that test value. I don't have much space because I got the next problem right there. Step 3 is compute the test value. How do we do that? The formula is there. You can memorize it. I think that's a good idea. But formula is here. Z-test, here it is. Here's the test value. Z equals x bar minus the population mean divided by the standard error of the mean. That's it. So Z equals, and you can get this in the calculator too. I'll show that as well. When I'm doing the p-value method, I will show how to get this test value right from the calculator. But from here, let's use our values and do the calculation. 3.924 minus the population mean that we're talking about, divided by sigma 0.053, divided by the square root of n, which is 10. The assumption here that this is normally distributed, I don't know if it says it here, but that's our assumption. We can assume that reasonably. Let's 3.924 minus 4.098, close parenthesis, divided by 0.053 divided by square root of 10. Make sure you put your numerator and denominator in parentheses, right? Numerator in parentheses, denominator in parentheses, or else your calculator is going to do some strange stuff. Z value, negative 10.38. That's the test value, negative 10.38. Why is this test value important? Because our next step now is to make our claim, is to determine if we're rejecting or not rejecting the null hypothesis. Make the decision. Reject or not reject. How we do that using the traditional method. You analyze this z-test value. You're checking to see this z-test value is either going to be greater than your critical value or less than your critical value. It's either going to fall in this region here, in this alpha region, this significance region, this rejection region, or it's going to fall in the non-rejection region. If this value falls in the non-rejection region, do not reject the null hypothesis. If it falls in the rejection region, reject the null hypothesis. So negative 10.38 is definitely less than negative 2.33. It's in here. So the decision is to reject the null hypothesis. Reject H sub 0. And here's our last step. Tell what's happening. Now, because we're rejecting this null hypothesis, we're rejecting this, we can say, okay, there's enough evidence to support this claim. There is enough evidence to support the claim that gas in Texas is significantly lower than the national average. I have to use a lot of shorthand here to fit all this in, right? So we rejected the null hypothesis, so there is enough evidence to support this claim that the population mean is less than 4.098. That's the traditional method. That's it. P-value method is going to seem shorter. State the hypothesis, compute the test value, find the p-value. We're going to do all of this in the calculator. So here's what we do. So I'm going to go to stat, go over to test because we're doing a hypothesis test. But remember, we already answered the question. I'm just showing the whole process. We're going to go to z-test because this is a z-test. And you can either use data that you input into your columns, L1, L2, what have you, or you can enter the statistics like we're given here. We're given the statistics, let's enter them. Population mean is 4.098. Sigma is 0.053. Sample mean is 3.924. You need to have all this information. And n, how many values we have? N is 10. And then it asks you, is this not equal to, less than, or greater than? In our case, less than. Go down to calculate. And so look. See, it actually, this is how you find the z-test value in the calculator. It actually gives us the z-test value, negative 10.38, the one that we did this calculation to get. And here it says P is 0. Now here's the way the P method works. If p-value is less than or equal to alpha, reject the null hypothesis. If the p-value is greater than alpha, do not reject the null hypothesis. So where does it lie here? If the p-value is, so the p-value in our case, p-value is 0, and alpha is 0.01. So the p-value is a little bit smaller, but it is less than alpha, so reject the null hypothesis. And we get the same exact determination that we did using the traditional method. You can use either method you like. So let's do number 13. At a certain university, the average cost of books. So they're telling us the average cost at the university, that's our mu. So our population mean is $360 per student. And the population standard deviation is $80. So this tells you Z all the way. Sample of 55 students, N is 55, gave us an average of $395 per student. Okay, so let's do traditional method. Well, we can't because we're not told the alpha level. So we can't go all the way with this one. We're not told what the alpha level is. We can do the null and alternative, though. Null hypothesis is that population mean is right at the same, $360. But the dean of students believes, which is what we're testing, that the costs are greater than $360. That's the claim of the dean of students. That's step one. Step two, we can't do. We don't have alpha. So we can't do that. But step three, the test the value, we can either do it in the calculator or we can use that formula again, x bar minus the population mean divided by sigma over the square root of n. I'll do it here. You can use the calculator if you choose. Okay, so let's see, 395 minus 360, close that parentheses, divided by, open parentheses, 80 divided by the square root of 55. 3.24, that's our test value. And the answer to our question, 3.24. Now let's just try it for fun in the calculator and see if we get the same. Stat, tests, z-test, let's input these statistics. So 360 for the population mean, 80 for sigma, 395 for x bar, and 55 for our sample size. And this is a greater than. Let's calculate. So 3.24 is in fact our z value. So there we are.